Hello, everybody. My name is Sanchit Srivastava. I am a senior manager, data strategy and analytics architecture in General Mills. And today I'm going to share with you how data architecture needs to change a bit to support agentic insight and actions. We will talk about how AI-driven data architecture looks like. We'll unwrap all the layers involved in that data architecture layer. We will see what MCP has a role to play in it, and then we will look into agentic approaches which can help us to get accurate AI enabled. Moving further, I'd like to start with a story, with a small story. How data and AI look separated and how will this work out? So this is a poem which AI generated for me. I'm a believer in AI. And it is like this. AI once streamed with power and pride, but data was scattered nowhere to hide. Queries were slow, the context was bare, and AI would stumble lost in thin air. Data grew weary, fading from light, ignored and mistranslated night after night. But just when hope began to fracture, comes a matchmaker called architecture. Now hold your breath, the story is not done. Let's see how this hero helps AI finally run. So that will be the goal, how architecture is an important component to ensure this relationship between data and AI works great and drives technology forward. Without further ado, right, as I introduced, right, we're going to talk about AI-driven data architecture, why, what, core components of it. We'll unwrap every component, and then we will summarize it with a money slide of every layer. But what is AI-driven architecture, right? I think let's start with that, right? We have seen all the evolution of data architecture back from the relational database to Teradata's of the world to data lake and now hyperscaler. But modern data architecture is probably a step ahead, right? It is a data layer. It is a data architecture which should support all kind of data, relational, semi-unstructured, unstructured, and highly unstructured data. It should support real-time data processing bare minimum, right? Recency is going to play a big role in agentic enablement, and we cannot live in a data architecture where real-time is still cumbersome. Insights, actions, analytics, more and more will happen through natural language query. So we need to have architecture which supports natural language query quite easily. And then, as always, a data architecture which can serve itself as a product, can serve itself as a service. So has to be open, has to be integrable through different kind of integrations. These are the 5 key pillars I feel as of now where we stand are the pillars for AI-driven data architecture. But why do we need that shift? I'm pretty sure all of us have seen what AI is doing to the technology landscape, what potential AI has in the data world, right? At least what we are seeing in the last couple of years is the demand for data has increased, right? It's significantly skyrocketed. Data is not generated by business. Data is not driving the business, which is a great thing for data professional like us. Now with LLMs coming in and the ease of LLM getting operationalized, unstructured data is a huge, huge scope which exists in data space. It's a huge unlock. Videos, audios, images. There is tons of information which I think any modern data organization should use to generate insights and analytics on it. Uh, Zero latencies, as I indicated before, is a must for AI, right? So we need to have data which is not behind operational systems. And machine are the future which will interact with the data, right? So we need this data architecture to shift because machines are going to be a real consumers going forward. And that's why a shift in the architecture is required. This is the gist of why there are many reasons, but I think these 4 big pillars cover the gist of it. But what are the key components, right? We are now going into details that what are the key components for our AI-driven data architecture. To answer that, right, let's understand what it means when data is interacting with AI. What you're seeing right now is a sequence of events when a machine, a LLM, a agent, a NLQ, application works with your data. As the first step, an end user or another software can ask a question in natural language to your data. Now, that question needs to be opened up to be answered properly. And what do I mean by to be opened up? It needs to understand what is being asked. It needs to understand what are your data elements to answer that questions. And then it needs to go at the exact tables and fetch the exact attributes to create a SQL and then render it out on the front end. How does it work, right? As I said, first is going to be NLQ, a simple English language or any language-based questions hitting our systems. We need to have, as the next step, we need to have these questions understand how a certain question needs to be answered. For example, if there's a KPI involved, it needs to know what that KPI really means as related to this organization. So you are looking at as a universal semantic layer kind of approach or a metric store data layer where all the enterprise definitions are defined and are available for every AI to derive that KPI on a consistent basis. Once your AI understand this question needs to be the KPI in this question needs to be calculated like this, it needs to know what it requires to calculate that to calculate that KPI, what columns it requires, what table it requires. And then you are looking at a context layer, right? Or you can call it as a RAG layer, right? A RAG context RAG layer. This layer essentially will have all kind of business glossaries, your metadata, your relations, right? Which will tell this NLQ question that a certain table or tables needs to be joined in a certain way to fetch a certain column to answer this question. So that's the step number 2.2. Notice that your prompt has enriched behind the scene with the induction of universal semantic layer or a KPI definition layer plus a context layer. And now you can expect a much more accurate SQL, which is converted through a natural language to hit your database. But that's not it. Context is also living context, right? So you need to have a service which is watching your data layer, what kind of queries are hitting it. Those are called golden queries concept, right? Uses patterns. Enrich this question with the understanding of this uses pattern, golden query profile of your data to make it much more accurate, much more robust. And then the query hits your data, runs the query based on KPI definition, which is certified, context, which is stored in your data layer, context, which is a live metadata context, depending on the historical use. And then the SQL hits your data layer, significantly increasing your accuracy and then rendering the output on the agent or an NLQ tool. A large part of this do not exist in data layer as of now, right? We do not have active metadata. We do not have context in the way the context is required as of now. And universal semantic layer are there, but are rare as of now. According to me, going forward, these three are going to be the pillars to drive agentic driven insights or analytics and will drive the accuracy of AI solutions significantly. Now notice there's an MCP icon, right? This is a challenging architecture. You're looking of creating a context store or you're looking of creating a metric store. But with the evolution of MCP, if you already have those things, you can stand up a MCP server and have your AI integrate to that MCP server and then hit the database layer. That is going to simplify your architecture significantly. Having said that, MCP is an evolving technology, so please be watchful and be interested in this technology. I covered a lot. Now let's flip it in terms of a data architecture. This is a sequence of events, but how do we achieve it? This is a typical data architecture, which many of the data architects or data modelers are used to, right? You have an ingestion layer. There are changes required in the ingestion layer too, and we will see that in the core component slides. You will continue to have your modeling layer, but your modeling layer requires a little bit of editing, and that's why the edit icon there. Data serving continues. You will continue to have your data serving layer. If you have a EDW or a semantic layer, that continues to be there. But the data context layer is going to be new, right? So you can use your cataloging tool. You can use your, your documents. Or if nothing works out, and if you do not have a context layer, knowledge graphs are a good example for creating context layer. But you can have all of this enabled through MCP, right? Instead of creating integration points with the AI. And then the new layer, the AI tuning layer. All this data already exists, but you need to tune this data for AI to work. That is where I think you can have your intelligent data layer. This is the machine-oriented data model layer we spoke about, plus a universal semantic layer where all the KPIs are defined. And notice there's another layer called fine-tuning layer or the RAG layer. I've called it as later because after having a semantic layer, universal semantic layer, a modeled data layer, and a context layer, chances are it will work out for most of the industries. So you do not have to do fine tuning. You do not have to fine tune a LLM, or you do not have to continuously RAG your data stores. But if that does not work out, I'm going to show you what options are to create a RAG layer or a fine tune layer for your LLMs. But for now, this is going to be a later. And then your next is your analytics action layer, where your conversation NLQs and AI agents are the new patterns of action or insights to be generated by your consumers. One thing to call out is observability is going to play a big role here, right? I think industry has adopted data observability pretty well. ML observability has been doing the REMs also in the past, but AI observability and agent observability are going to be extremely important, and we will see a bit of this too. Now, another diagram, right, to just showcase this. If this is only focused for the data guys, right? So if you have EDW, if you already have existing data layer, think of creating of AI hubs, right? These AI hubs are essentially modeled, consistent, recency is good, right? Data layers, if you already have those, don't have to invest in those. Data context layer is the key. If you do not have that, you need context around the data, and then universal semantic layer is the new component here. But the data will be moved from EDW to AI hubs, parallel to it is context layer, upskilled is semantic, and then universal semantic layer feeds into your consuming tools, be it agents, be it NLQ tools, or be it your BI tools. And these tools can have their own native semantic layer too, which is nothing but a subset of universal semantic layer. A knowledge graph could be the solution if these three components don't work. Okay, let's unwrap them, right? Let's start unwrapping the first layer, which is your ingestion layer, right? So let's understand this. Now, ingestion layer, right, it requires changes, right? So far in a traditional data warehouse, we ingest a lot of structured data and a lot of semi-structured data. But the time has come to start dwelling into ingesting unstructured data, right? PDFs, images, videos. LLMs are very good in doing that. Um, you should explore with LLMs, ingesting data. There are objects available now which can store unstructured information along with structured information in the same tables. So something to look out for. GCP has a feature called as object ref. Great feature to explore, but be ready to ingest unstructured data, and AI can help you significantly in doing that. And then vetting of raw data is extremely important now, right? Uh, as I mentioned, recency is going to play a big role. Data has to be real-time enabled. And in many cases, this data will reach out to the end consumers, the AIs of the world, in very real time. So constantly observing the data at the raw layer is becoming a need of today. So this is something which a mindset shift is required when we are ingesting the data. Now, modeling layer, right? Traditionally, we have been modeling using star schemas, snowflakes, federated, right? There are multiple modeling techniques. We should continue doing that. But model for a machine now, and we will unwrap the intelligent data layer on the AI tuning layer, right? What is the basic a machine expects on a data layer to understand and drive a right SQL from it? Model it, keep that in mind. Cost optimization is going to be the focus, so continue doing that. Leverage AI for data quality, right? So you can have machine learning models observing your data and be proactive. If they identify any anomaly, machine learning models can trigger those anomaly alerts to you to any developer, and before it goes downstream, that can be fixed. Going to play extremely big role in the agentic world, right? Use code assist, use AI to generate the codes, use agents to generate the code, right? It helps significantly. Self-healing assets are becoming a reality. Having AI over your CI/CD practices significantly help and accelerate self-healing assets. So something to look out for in your modeling layer too. And then finally, the current serving layer, right? This is the layer where things will change significantly. We are going to serve to AI. We are going to serve to, simple English language based tools. Uh, the current serving strategy of APIs, reports, somehow overlaps, but not entirely overlaps. So we will have to build a serving layer to serve for AI agents and to serve for conversation analytics. And there is where the intelligent data layer will come into picture, and we'll talk about it. Right before the traditional data layer, just on top of it or alongside it is the context layer. Now, this is a layer which per se do not exist at this point of time in many of the organizations. But why is this context important, right? Well, context is important because a lot of the insight generation development work, a lot of ML engineering or feature store engineering is done by human beings. And these are the human beings who develop the context about the data. They handle all the nuances. They write the code around the data because they understand the context. So that's why the importance of context doesn't show up. The magician in a developer handles the context hallucination, if I can call it so. But soon, AI is going to be a magician. We are heading into the world where AI machines, AI agents are going to answer the questions on the data. And this layer of developer, a human being, handling the concept hallucination will not exist. So that is why organization needs to start investing in building a context layer, a quality context layer, which can help AI understand about your analytics data, what your analytics data is all about. This is extremely important for any NLQ question thrown on our data to enrich the prompt and get the right answer. The contexts essentially are two types, right? We already saw why it is important, and but the point I'm saying is context is essentially are of many types. There is just metadata, right? So in your intelligent data layer, make sure you have right metadata defined around your attributes, around your data sets, around your tables, around your warehouse. Tag your tables, what kind of business capabilities those tables can serve. You know, add descriptions, add keys, logical keys. If you do not have keys yet, right? Add keys information in your tables. That gives a lot of knowledge to AI to understand which attribute to go for and how a certain table is related to another table. These are all stale metadata. This is all stale context. This does not change, right? AI also relies on active metadata, which means how a certain table has been used in the past, how a certain question has been answered in the past. So not only we need to build metadata around our structures, data structures, we need to capture the uses, the user patterns to give AI active metadata information. The lineage information is extremely important for AI to draw the entire relationship dependency of for a certain question. If an organization is not investing in building it, struggles would become a reality. So strongly recommend for anyone who is investing in AI-driven data architecture to think of context store. If you have a cataloging tool, it can act as a context store. MCPs, as they grow and as they become more scalable and secure, is a great way of pushing all that context which already exists on your cataloging tool to your AI LLMs. But make sure metadata, table tagging, attribute tagging, relationships, your business context, business acronyms around the data, these are all making way to your cataloging tool. And then in your hyperscaler, if you have a hyperscaler, or if you are in traditional data warehouse or a iceberg architecture, there's always a way to understand users pattern, grab that information, store it somewhere for AI to understand and enrich our NLQ query. This is a new layer, something to watch out for. Now, we have done typical data layer. We saw what changes are required there. We spoke about a new context layer. Let's move about the new layer, the AI tuning layer, right? Now, if you are a traditional data warehouse, that alone is not going to work. That used to serve very well for data science solutions or reporting solutions. But AI demands a bit more, right? And I call it as intelligent data layer, which is empowered by machine-oriented data modeling on data architecture. Right? So make sure any data asset which is getting exposed to AI has these top four qualities. They need to have metadata which are consistent. Inconsistent metadata, inconsistent naming standards will lead to hallucination. So invest in quality management of your metadata and data modeling too. Make sure you are not living in a relationable world anymore. Almost every data storage right now has a way to showcase a logical relationship. Make sure you are doing that so that your AI knows how to relate to tables instead of generating that relationship by itself. Tag your tables, right? Tag your tables by your business capabilities. What business capabilities a table can serve. And sometimes in my experience, mentioning what it cannot serve works really well with AI. So do that. Have standard KPI definitions, standard metric definitions, standard values across your data layer. This goes back to our semantic layer, and we will talk about that too. And if your data layer is just not serving the purpose, knowledge graphs are a way to go to, but there are different kind of modeling. It requires a huge lift. But definitely explore this. If your data layer is not working, explore the ontology side of your data layer first before going all in with graph databases. So this is how a machine-oriented data modeling does. It needs context of your data. It needs consistent values. It needs consistent definitions. It needs relations to crawl across the data model, which a report or a feature model does not require at this point of time. In addition to an intelligent data layer, you need an intelligent semantic layer too. So very soon, asking questions around a KPI, around a business KPI will become common through an LQ. What you do not want is leave it to AI to understand what a revenue KPI really means. Every organization defines their revenue, defines their sales very uniquely, and defines their KPIs very uniquely. So you need a repository to store those calculations and make those calculations available to AI. So invest in your intelligent semantic layer, right? Some semantic layer can just be the KPI stores. Some can also be a semantic model for AI to run. Another enrichment layer for a prompt to understand your relationships. So in this layer, at least have the context about your data, have the KPI definitions, consistent KPI definitions, and also use this layer for pre-caching if you can, right? This will help in your performance as the response is rendered out. If a question is being asked quite regularly, use this layer to pre-cache that question and present it out instead of going back and forth to your data layer all the time. Um, Another important layer, which has been in this industry for quite some time, but I think will gain traction just because we do not have that developer magician to handle context hallucination. With all this done, these are all components, right? But how do you fine tune, right? I mean, you have an intelligent data layer, you have an intelligent semantic layer, but how do you fine tune? There is where the vector databases and the knowledge graphs of the world come into picture. Now, remember, you don't have to do this as you get go right away, right? This is a costly proposition. This is a compute intensive proposition. This is a complex shift for a data architecture team to do. But this works. This is a traditional way AI has worked. Now, what are vector databases? Vector databases are nothing but it is a graphical, a multi-dimensional setup for every value which exists in your data store. And it helps AI to locate a certain attribute and a value which is in your data warehouse, right? So as you can understand, it is that location is essentially called embeddings, right? but it is not your two or three-dimensional embeddings. It is like hyper-dimensional embeddings, high-dimensional space environment we are looking at. AI loves this. AI works on the concept of nearest neighbors. And there are many fine-tuning techniques where you can pinpoint AI which vector to pick, which embedding to pick and answer that question. But as you can understand, this is your another data layer. You will have your data layer, and then for every data element, you will need to have a vertex store. And there needs to be a regular refresh mechanism for these vertex store to happen. Extra hassle, um, but certain data elements, especially complicated domains like healthcare, might really benefit from this. Right? Um, Traditionally, vertex databases work really well for search cases. Right? So if your extreme right side is all about searching, vector databases are great examples for that. Another way is knowledge graphs. We already spoke about that. Has been in the industry for quite some time. Essentially, knowledge graph is a way of creating relationship across your data architecture, and with the relationship moves the data. It gives AI a understanding how your data is related, and hence it is able to get to a much more accurate answer. Clearly, a very different way of looking at the data, a very different way of modeling the data, right? So as I said before, should not be your get-go options. Your get-go options should still be context and a universal semantic layer with the metadata on your data. But this traditionally has worked great in the past, right? It serves AI applications providing the right context, right? So to get output of your data. Knowledge graph is a good candidate for your context layer. If you do not have a cataloging tool as of now, if you don't want to go to the MCP route, you can load your context in a knowledge graph, and it will definitely add value to your AI accuracy. And then the third way is, right, if you already have the pieces in place, you have cataloging tool in your environment, you are capturing active metadata too, you already have your glossaries in some way or fashion somewhere. MCP is a lightweight solution for AI to understand what exists around your data. Now, MCP is very new, but it is going to be powerful, right? It helps AI add context about the question someone had asked, right? Um, so think of building an MCP on a cataloging tool. Think of building MCP on your USL tool. If in your universal semantic layer tools, you do not require to move the data from a catalog to a knowledge graph or to a vector database. You do not require to refresh between these two data layers. MCP is auto refresh, and it is always living, always live. And it is also stateful. So it maintains the discussion which is happening with AI. I'm watching this space very closely. Strongly encourage you to watch the space. I think this will increase the ability of AI to understand data very, very well. Certain watchouts on MCP. Uh, Always try to host it within your VPC, right? It is a layer which can add security risk to your data layer. The security of MCP is not fully strong at this point of time, so definitely engage a security expert if you are spinning up a MCP server. Do not rely on MCP to enforce security. Have the security in your data layers, in your context layer, manage the way you are doing at this point of time. Also see if you can hook up your MCP servers to observability tool to stop any malicious prompts. So a lot to evolve here. Next time when we meet, we can talk a lot about MCP, but this is a space worth watching for because it gives tremendous power to AI to understand context around the data. Now we have a good data layer, intelligent data layer we spoke about. We have a good semantic layer. We spoke about how can we make our data layer much better with vector databases and knowledge graphs, and MCP can help in bringing context around the data. But how are we going to fine tune it? So now you have an approach called RAG. All of us know RAG. RAG stands for Retrieval Augmentation Generation, right? We can create RAG data stores on your data. We can create RAG data stores on context layer and have LLMs go through RAG before it presents a solution. RAG does two things. It adds context to the question asked, and it filter out the response because it is RAG to your data. It is RAG to your context. Hallucination reduces significantly when you're RAGing. But again, RAG is a layer which you have to keep refreshing. All the RAG data stored needs to be keep refreshing, but it helps in accuracy of AI significantly. You do not have to train LLM for that. It's a low cost solution, but at scale RAG is something which modern organizations should think of, um, but it will be compute intensive. Second option is use your data to fine tune LLM. Do not encourage this option if you are just starting into AI world. Fine tuning LLM is probably the best way to do it, but it is very compute intensive, very cost intensive, and error prone. His research says that if you're fine tuning a LLM, there is a possibility of fundamentally changing a LLM behavior. So don't do fine tuning right away, right? But if you have to do it, um, and do it in a non-prod environment, requires a lot of A/B testing, requires a lot of pre-trained data, quality trained data for the fine-tuning LLM to work as expected. Um, it is costly, keep that in mind, and it will be a huge cost computing solution for any organization. So now we have an intelligent data layer, we have an intelligent semantic layer, we saw about MCP, we saw RAG and fine tuning. What does this all tell us? It tells us that if in a modern data architecture, you have a data layer which is consistent, which has metadata on it, which is relationable, which is being observed, thereby enforcing the quality is good. You have a semantic layer which is certifying all the KPI definitions. And you have a context around both data and semantic layer. You can use RAG or you can use all these components to fine tune an LLM and generate the accuracy of AI. This, this, this reduces hallucination and reduces the ambiguity significantly. And thus, this component of data layer is going to serve our AI agentic solutions, AI solutions much better, and they are built for future. Let's talk about the last layer, which is changing significantly now, right? The insight in the action layer. And I want to quickly dive into what are agents. We are seeing agents. There's a lot of hype around it, and I'm pumped for it, right? The key difference between agents and traditional insight layer is agents are autonomous, right? They will do things by themselves. They learn. They know what they're asked to do. They can understand, and based on their understanding, they can take actions. They can now they can reason within themselves, and they're autonomous. This kind of insight or this kind of action did not exist yet. There was a flavor of RPA, but RPA still has a very confined boundary. The reasoning capability did not exist, but AI agents are scaling out the boundaries. So for me, agents are nothing but LLMs plus memory, plus reasoning, plus actions, plus planning, right? There is, and each component of this is very complex and interesting by itself. But I also feel if you give agent the right data in the right way, the right KPI definitions at the right time, and the right context on where to go and how to go to fetch this information, agents will serve us very, very well. What are the boundary between an LLM and an agent? That's a very good question, right? LLM is essentially is all about understanding, and it's a step one response mechanism. Agents are beyond that. They are a task-oriented system, right? LLMs are very passive. They won't do something they won't do something by themselves. AI agents they take actions, right? They're very reactive. Most of the time, LLMs are, they are now generating images or videos a bit, right? Or text is their core strength. AI agents can take actions. It can trigger an email. It can trigger another agent, which can trigger a dashboard or can trigger a program, right, to do many things. GPT-5 now can place orders for us, right? So agents are really pushing the boundaries now. For LLMs, mostly the scope is language processing. AI agents are not going beyond, right? Placing orders, taking orders, right? It's more action oriented. LLMs are very low in autonomy, right? While agents are pretty high and pushing further. LLMs are basically the model itself, an interface on the model. Agents use the model plus spanning, reasoning, memory exchange, protocol, communication protocols, and whatnot. Evolving word. So I expect AI agents to scale further. Now let's just quickly talk about AI agents. I know this is a very fast-moving space. Multi-agent architecture is gaining traction. We all have heard about Crew AIs, LangGraph, Llama Index, whatnot, right? But I quickly wanted to share what a multi-agent architecture should look like. I mean, looks like, and what are the key elements in that. A multi-agent architecture essentially is where we have multiple agents controlled by a master agent. Master agent knows what kind of agents are available to it, and it does that, workload management. With A2A, which is agent to agent communication protocol, agents, the worker agents now can also share informations within themselves and get a bigger task done by themselves. So what are the key criteria, focus things in a multi-agent architecture? Handoff mechanism is going to be important, right? How is a agent handing off the work to another agent or to the master agent? There is where I think A2 is going to play a big role. Network management, you should not have network latency, right? So how to manage the network in a multi-agent architecture is going to be important. Supervisor control, right? Master agent is going to be critical, right? Security, access management, routing of the request, parsing of the request will be all done by a master supervisor agent. So that is going to be control. Hierarchical control goes along with it, right? And then context sharing. How are agents sharing the context? Because agents will solve the problem which involves multiple specialization. How are they sharing the context? So these six things I feel are going to be extremely important if you're building a multi-agent architecture. Very evolving space. Big players, to start here are, if you have not done LangChain frameworks, they are pretty good. Crew AI is pretty good. Llama Index is another pretty good. We built something on LangChain and has a multi-agent architecture and has worked pretty well for us. And the final layer, right? This layer has existed. This is essentially data as a service layer. Um, I in a modern data architecture, we should move away from file-based sharing or table-based sharing. I think we should move towards the world of data exchanges, clean rooms, data transfers, analytics hubs. This is the low code, no code, low cost way of sharing the data with a lot of security walls around it. So focus for a modern data architecture organization, focus on these two ways of sharing data, data exchanges, data transfers, data clean rooms, and data as a service will always have APIs around it. So build it in a way that you can always have a system API over it if it comes to that. The last but not the least, with data gaining traction, with AI gaining traction, with agentic gaining traction, I think we are heading towards the world of a unified observability. Make sure your data is observed, not just the quality of it, but not just the monitoring aspect of it, but the lineage, collaboration, process quality, data resolution, right? Have all of these covered and done by AI. Similarly, on AI observability side, you need to be watching your model drift, model correctness, latency. Is your model doing well in case of PII data? Is there a bias getting into it? What kind of protections you want to put in place as an organization? Have all of that and let AI observe all of it for predictive and general AI models. And as both data and AI feeds into an agent, agent observability is also going to be extremely important. How agents are making a decision, what is their thought process, what is the decision metrics looks like, what is the scope for an agent, how is the agent restricting to that scope, is the handoff context sharing happening in the way you want an agent to do, tracking all of that through AI, monitoring and observing and raising alerts through AI on all of these aspects are going to be extremely important. So unified observability for a modern data architecture to me is data observability, AI observability, and agentic observability, all through AI is the world I think this a modern data architecture organization should move towards. Now the money slide, I spoke about that for every of these components, I will share what 2, 3 things are extremely important. So let's do that. For ingestion, have schema evolution. So be ready to ingest anything any data, structured, unstructured, semi-structured, images, PDFs. right? Build it for speed, right? Build it, latency should be near real time, right? Should be zero latency. Modeling, right? Model for AI, model for machines, have metadata, have relations, have consistent values. Make sure you are, if you can store your unstructured and structured data together, that's great. That's great for AI. And use AI for modeling faster. Data serving, right? Don't do file exchanges anymore. Go for transfers, exchange, hubs, APIs. This is a way for a modern data architect to serve the data. AI tuning layer, right? Invest in building a intelligent data layer. And we saw what the components of a data layer is. Invest in building a universal semantic layer or intelligent semantic layer so that AI does not derive KPI definitions every time. Your data layer should be very well versed in data recency, should be near real time. Absolutely no redundancy, absolutely no inconsistent data values. Be very consistent, be very strict on those aspects, and use AI to add metadata and beyond, right? Should have live metadata as well as stale metadata for this data layer. And then we spoke about the tuning, right? So you can always go vector databases or MCP route or knowledge graph routes to fine tune if it comes to that. Conversation analytics should be done on your intelligent data layer using your context layer and your semantic layer. That will make your NLQ quite efficient and quite accurate. AI agents, again, should be done through your IDL, SL, and context layer. Make sure your guardrails are there. Make sure your memory sharing mechanisms is there. Make sure you have a way to observe your agent as well as AI models. And last but not the least, universal observability. We spoke about how important it is going to be in the autonomous worlds of agents. And then the context layer definitely is required to add accuracy and reliability to your AI components. If you have all these places, remember we started with the poem where both data and AI was too far. If when you have all of this, let's see what happens now. In silos, they lived, both data and AI, one grounded in truth, one dreaming to fly. Data, the wisdom, so vast yet unseen. AI, the artist with vision serene. So far they do not have IDL, ISL, USL, context. None of it is done. But now let's see what happens when architecture does it. Then entered architecture, structured and wise, bringing their word, it's opened their eyes. Context enrich every byte, made the grounding precise. Relationship mapped, knowledge graphs would entice. Metadata whispered the who, what, and why, while observability let insight amplify. MCP stood central, the orchestrator clear. Embeddings brought neighbors contactly near. LLMs turned finely, so meaning was clear. With grounded and fine-tuning, hallucination fell. New data and AI in harmony dwell. Now, hand in hand, they power the dream. From chatbots to agent, they are the perfect team. So with the right architecture, with the right data layer, right context layer, right semantic layer, right context to your AI, there is huge potential to make AI generate accurate, reliable, consistent insights and actions, which is where the world wants to go. So it's not just modern architecture is not just a technology. It is essentially important for both data and AI to work together and drive meaningful, reliable, actionable insights. Perfect. Well, thank you for your time. Happy to answer any questions.